Hi, Mr. Green here. I'm going to take you through the next section of the Physics AQA GCSE, which is based on acceleration. Our learning objective is to explain an object's acceleration. If you take that down as your learning objective, please pause the video whilst you do that. Okay, so I have some retrieval questions to start with. If you could pause the video and attempt all 5 of these questions. Okay, question 1. Is speed a scalar or a vector? Speed is a scalar quantity. It has size, but it does not have direction. Question 2. Is velocity a scalar or a vector? Velocity is a vector. It has size and direction. Question 3. Is distance a scalar or a vector? Distance is a scalar quantity. Size only, no direction assigned. Question 4. Is displacement a scalar or a vector? Displacement is a vector quantity. It has a direction as well as a size. Question 5. Which equation links speed, distance and time? Speed is equal to distance divided by time. Okay, our learning outcomes today are to define acceleration and to calculate the acceleration for different vehicles. Okay, so what is acceleration? When describing the motion of objects, we often refer to their velocity. We don't refer to the speed. This is because velocity is a vector quantity. Vector's got size and it's got direction, so acceleration has a size and a direction. Sometimes objects can move with a constant velocity, but the velocity of a moving object can also change. It's not always constant. The rate of change of velocity is referred to as acceleration. So how quickly something changes its velocity, we refer to as the acceleration. Calculate acceleration using this equation. Acceleration is the final velocity, take away the initial velocity of the object, divided by the time taken for the change. That gives us the rate of change of velocity, which is acceleration. We can also use this equation. Change in velocity divided by time taken for the change. Our units. Acceleration is in meters per second squared. Velocity in meters per second. And time taken for the change in seconds. Again, really important that you know the unit for acceleration, meters per second squared. We're dividing meters per second by seconds. It gives us meters per second squared. Okay, so with that in mind, could you answer these 6 questions? Please pause the video whilst you attempt them and then restart once you'd like the answers. Okay, so when do we say an object's accelerating? We state that when it's changing speed, when it's changing direction, or both. Remember, because it is a vector quantity, changing direction would also be a change in velocity. What happens to the velocity of an object when it accelerates? It changes, so it always changes when it's accelerating. Is acceleration a scalar or a vector? Acceleration is a vector quantity, it's got direction. And what's velocity? And is that scalar or vector? Velocity is speed in a certain direction, so it's a vector quantity. If an object is travelling at constant speed in a circle, is it accelerating? And explain your answer. We need to again remember that direction is part of the part of velocity. If direction changes, velocity changes. So an object travelling at a constant speed in a circle is accelerating because it's constantly changing direction. And if it's changing direction, that means its velocity is changing. The definition of acceleration is the rate of change of velocity. So if direction changes, or the speed it's travelling at changes, then we have changed the acceleration. We've changed that velocity, it's accelerating. Okay, so a quick example on using the equation. A car accelerates from 10 meters per second to 25 meters per second in 5 seconds. What's its acceleration? So we put our equation down. Acceleration is change in velocity over time taken. We start off with 25 and we end up on 10. So with 25, take away 10 gives us 15. So it's increased by 15 meters per second. It's taken 5 seconds for that change, so that's 15 divided by 5, giving us 3 meters per second squared. Car accelerates from 20 to 35 in 15 seconds. What's its acceleration? So from 20 to 35, we get 35 take away 20, giving us 15. It's taken 15 seconds for that change, so that's 15 divided by 15, giving us 1 meter per second squared. Okay, after those examples, please pause the video and attempt these 6 questions. They will all be using the acceleration equation. Off you go. Okay, so question 1. Car travels from rest to 65 meters in 10 seconds. What's its acceleration? From rest it's 0, so the change would be 65. It would be 6.5 meters per second squared. Car travels from rest to 56 meters per second in 56 seconds. Its acceleration would be 1 meter per second. Car is travelling at a steady speed of 76 and its velocity changes to 98 meters per second in 93 seconds. What's its acceleration? Well, the change in velocity there would be 22. That's 98 take away 76, giving us 22 divided by 10, 2.2 meters per second squared. Okay, question 4. A cyclist accelerates from 0 to 8 in 3 seconds. What's its acceleration? That would be 8 divided by 3, giving us 2.66 meters per second squared. Okay, question 5. A car advert states a certain car can accelerate from rest to 70 in 7 seconds. What's the average acceleration? Well, that would be 70 divided by 7, giving us 10 meters per second squared. And the lizard accelerates from 10 meters to 2 meters per second in 4 seconds. What's its average acceleration? Well, if you see, it's going from 10 to 2. So we do 2 take away 10, giving us minus 8. Minus 8 divided by 10 gives us minus 0.8 meters per second. What does that minus mean? Let's move on and see if we can work that out. Now, acceleration is defined as a change in velocity in a given time, and velocity can decrease as well as increase. Now, when velocity decreases, we can also call it deceleration as well as acceleration. So what's the deceleration when a car slows from 18 to 10 in 5 seconds? We would do 10 minus 18, so that's final velocity minus initial velocity, giving us minus 8. Divide that by the time, which is 5, it gives us an acceleration of minus 1.6 meters per second. It's accelerating in the other direction. It's not speeding it up, it's slowing it down. So if it's decelerating, we give our acceleration a minus figure. Deceleration is always negative because acceleration is a vector quantity. So deceleration is acceleration in the negative direction. Okay, so we can also use the acceleration equation to calculate the other values in the equation just by rearranging the equation. So I'm going to ask you to rearrange that. Could you rearrange the equation A equals v minus u divided by t to make t the subject? The way we do that, A equals v minus u over t, so we'd rearrange it. T equals v minus u divided by a. Final minus initial divided by acceleration. Rearrange the equation to make v minus u the subject. If we do that, v minus u equals time times acceleration, t times a. Rearrange the equation to make v the subject. Works out like this. V equals u plus t times a. It's minus u on one side, so it becomes added to u on the other side. And finally, rearrange the equation A equals v minus u over t to make u the subject. That would be u, or initial velocity is v final velocity minus time times acceleration. Get those down because you'll have to use them for the next part of the lesson. Okay, so 5 questions there. I've mislabeled the bottom one. Could you please go through those and answer the questions using the equations you've got? Pause the video and restart it when you'd like the answers. Okay, so question 1. Correct answer is 6.67 seconds. Question 2, 2.5 seconds. Question 3, 120 meters per second. Question 4, 6 meters per second. And the final question, labelled as 4, but actually question 5, 44 meters per second. Again, if you have any issues with any of those answers, please pause the video. I'm giving you the way that I've done the equation on there, so please read through those again. So what affects the acceleration? Which of the 2 cars above would have the biggest acceleration from rest and why? Pause the video whilst you answer that question. Okay, so the second car would have the biggest acceleration, and it's for 2 reasons. Because number 1, its engine can provide a bigger forward force. We know from previous work, force equals mass times acceleration, so if it can provide a bigger force, that's fine. The other way is, its shape reduces the backwards force it would experience from air resistance, so it's streamlined, so the force that's pushing it back isn't as big as on that first car. It's got a bigger surface area, lots of air would be hitting that. On the second car, air can smoothly travel over it. And how can we measure acceleration? Well, we'd need the equipment that we've got above there. We'd need a trolley that's linked to paper ticker tape, vibrating pin and carbon paper. Trolley's attached to a ticker timer, and this ticker timer leaves a dot on the carbon paper every half a second. What we'd do is we'd allow the car to go down the trolley there. Then we collect the tape from the full run and cut it into 4 tick lengths. We know that if there's 4 ticks on that, the time is 2 seconds. We'd then measure the length of each one, and this is the distance the car's travelled in those 2 seconds. If we keep them in the order from when it started to when it ended, we can now work out the acceleration. Using the distance we've measured and the time taken from the number of dots, we calculate the velocity for each 2-second portion. If we take the velocity from the first tape and the velocity from the final tape, we'll get the increase in speed. If we count the total dots on all the tapes, we'll get the total time taken, and from this we calculate the acceleration from the change in velocity divided by the time taken. Okay, that's all from me concerning this. Please subscribe to our YouTube channel and review any of the videos as you see fit to increase your science knowledge. Thanks very much for your time. See you soon. Goodbye.